Yeah. Well. So yesterday, I gave some definition of the very fundamental exact sequence of a fundamental group. Sorry, X bar X. I omit adj from now on. Going to the absolute, and for the simplicity, from now on, I always assume that our field is Q. Assume, just for the simplicity. And this is defined as a Galois group of field. And this is defined as same way. And today's theme is to have the Galois action. For this, first, I comment that if X is a Q rational point on X, so this is in terms of true definition of the fundamental group. This is pi 1 of spec Q. So if X is on Q rational points, then here is some section. So from spec Q to X. So the spec Q to X, the morphism like this is just the definition of Q rational point. So there is a section. And if once we are given a section, this element here is by sending by this section, it is an element here. And here we take inner automorphism by the element. Then, because this is normal subgroup, any inner automorphism, any conjugation by this element restricts to this element because this group, because this is normal. So we obtain the action of the Galois group to this profinite completion of the topological fundamental group. So the first one is if X is Q rational, then there is a section. And I abandoned the idea to explain about this completely. However, I will explain even more difficult thing. That is, if X is tangential base point, and from now on, this is again for simplicity, but I always assume that X is P1 minus 3 points defined over Q. So what we need to do is that to construct section to this short exact sequence, that is from the absolute Galois group to Galois group of mx over qx, Okay, so because I chose my favorite coordinate t to say c. So this is just the coordinate function of this algebraic variety. So q of x, so the meromorphic function here is just qt. And this section is given as follows. So we recall that we defined this as a jam of meromorphic function in the sense of analytic, in the analytic sense, jam around some interval where epsilon is maybe very small, so infinitely small, so just jam around this place, and which should satisfy some condition about analytic continuation and also algebraicity. Then one can prove that this field is uniquely embeddable into Cuba Puiseux series, where this Puiseux series is defined as a union of formal power series field, for Laurent power series, you say, but in terms of nth roots of T. So I don't, already I mentioned, I chose one branch of this function. So this is something living in here already. But then taking the union for all the natural numbers, and I need by here. So there is such unique embedding. There are several ways to prove that, and one way is to use the fact that this is algebraically closed. It is known that then, well, this is algebraically closed. And another way is, well, if we take any element h here, then this has finite monodromy because this is algebraic. So this is a finite extension over the Q bar t. Actually over Qt, but over Q bar t. So the monodromy around 0. So here is 0 and here is 1. So after several times going around, then this returns to the same function because of the finiteness. And let n be such number. Then one can prove that h can be expanded in terms of this one. Because by choosing, by expanding, by considering this as a function of n covering, then this becomes monovalued around around 0. But anyway, one can prove that there is a unique embedding. So now I think you can imagine what I am going to do is that this Galois group, let's act by acting at the coefficients. That is, this is fixed. This is fixed by the Galois group, but only the coefficients are acted by the absolute Galois group. Then it is not very trivial, but it can be proved rather easily that this function, this meromorphic function, is stable under the action of the Galois group. So which means that we have a morphism from Galois group to automorphism of M01 just by letting the action by the action of the coefficients. And it is also clear that any element of any element of Qt can be expanded in here. Very famous thing that so any rational function is how to say can be the expansion is inside this. So that means the Galois group trivially acts on this. So we have some morphism here, group homomorphism. However, I claim that this is a section. It's easy because the right map in the short exact sequence is actually given by this. And the canonical identification of this group with the absolute Galois group is by just letting act on the coefficients. So that implies that this is identity. So this gives a section to this short exact sequence. So,
excuse me.
yes.
Is the equation not equal?
This one?
Yeah.
These are global. This is, in some sense, global. So this may be, for example, non-algebraic over Q bar X. Welcome. So now, already I defined, the Galois action on the fundamental group. That is, it is associated to this rational tangential point going to automorphism of pi1 geometric. The sigma is mapped to S01 sigma times S01 sigma, and I put here inverse so that the action is from right. So this in now. So this is function mapping from this to this. So I think it's clear. And this group is a profinite completion of the topological one. And as I use this notation for the topological fundamental group, and this is generated by two elements. Unfortunately, I used the same letter x with the base point, but from now on, I will never use a base point except for those tangential ones. So from now on, this x is always an element of the fundamental group. And they are here. So here is 0, 1, and infinitesimally small vector here, and actually here also. It's mirror image. And x is this one. And y is this one. So if we replace this with an algebraic fundamental group, as I explained, we needed to take profinite completion. But still, by some abuse of the terminology, I use the same x to describe an element here. And what I claim is that this action is given by cyclotomic character and by the something which is the Galois analog of Drinfeld associator. But it existed before before Drinfeld associator. Anyway, first comment is that because this group is generated by these two elements, if we consider the topology, then generated by these two elements. So to describe the action, this action, it suffices to give the action on x and y. Then any other element is just product of these things, so the image can be computed. Because even this profinite completion, say, this is dense. So this map is dense. So if you compute the image here, then by continuous extension, you can obtain the automorphism here. So this is enough information. What I am claiming is that this chi and f are enough to recover the action. Well, so why this holds is now I am going to explain. But before that, I want to introduce some notion of did I put two? I'm not sure. Groupoid. But this is already introduced by Dick. I am very only give only the sketch, and always x is p1 minus 3 points. And the groupoid which I use is just this one. Yes.
What is the statement of theorem?
The statement of the theorem is that there is some number in profinite completion, and here is some element inside F2 hat, so this one. So the statement is that x is x to some power, y is mapped to y to some power, and its conjugation by some element. And actually, it lies in the commutator. And later gave proof that under this condition, F sigma is uniquely determined. So group theoretically, these elements can be, this element can be characterized. But actually, it is naturally follows from the fact that not that I am not, I don't define F sigma, but I will give the definition of F sigma very soon. To give the definition, I need this groupoid. I think I don't need to explain about this. This is just a path, any path. Yes? Ah. Yeah. You still remember? Thank you very much. Yeah. And okay. So, but here is a special element here, which is very important and is very trivial, is that this path, the most important path in the world, I believe. Then its algebraic analog to this groupoid is this one. Isomorphism of two fields over Q bar T. That is, this is a field which contains Q bar T, and this also contains Q bar T, and I don't define this, but this is just the mirror image of. So by symmetry, you can easily guess what is the definition of this one. And about the Galois action, this is embedded in Q bar from 1 minus T's nth roots. So just using the symmetry between 0 and 1, which actually Dick used in the last lecture. So this is the definition of pi 1 of algebra. Usually I omit, but to stress x bar 0, 1, 1, 0. And we have this homomorphism by analytic continuation. I think it's clear. So I'm not going to explain. Just I won't. So P is mapped to something which I again denote by P. Then I defined the Galois action on the algebraic fundamental group. But actually, because both these are rational point, Q rational point, we can define the action on this groupoid actually. Why? It's easy. Because for any element here, say take P, any element actually, but this action is denoted by rho 0, 1, 1, 0, because this action is depending on the choice of these base points. So rho 0, 1, 1, 0 sigma acts on P. P is an element here, now here, by conjugacy. That is rho 0, 1, P rho 0, 1, 1, 0, 1, 0 sigma P, and I should put here inverse. Why? Sorry, sigma. Oh, sorry, I am always making this mistake. This is section. Why? Because this S01 sigma is, it is very simple because this one is inside automorphism, okay, Galois group of M01 over QT. So this element acts on this from the right. How to say from the left or from the left? Okay, I am bad at English. so anyway, this one acts on this, and this one acts on this. But it fixes only QT. However, because we took conjugate, any element inside Q bar T, any element of inside Q bar T has action at the coefficient by sigma inverse. And even after analytic continuation, still we have the same expression in, how to say, same expression in terms of, so any element inside Q bar T is acted by sigma inverse at the coefficients, and one can prove, it is not difficult to see that even after analytic continuation, just what we need to do is to think an element here as an element here. Then this sigma acting by sigma inverse and then acting by sigma will rewind the action so that this itself trivially acts on this. So this is inside here. Thus, the Galois group acts on this groupoid. So this is P times something. Why? Because P is an element here. And this one is element in the same place. So if just putting P inverse here. Sorry. If we put P inverse here, it will give an element here which lies in pi 1 x bar 0, 1. Okay, because I think it's clear. Something. This something is the definition of F sigma. It is an element inside the fundamental group, not groupoid. And by this definition, F sigma is something like cocycle. Not exactly, but something like cocycle. Because it is a difference. It is difference. So this is P inverse this thing. This is the P acted by sigma, and we took the difference. So it is one cocycle. Not exactly. And next, I define the cyclotomic character. Cyclotomic character is this guy. This guy here, chi sigma. Oh, sorry. Cross. Well. So I want to prove this first. So what we need to do is, first we want to identify X as an element of algebraic fundamental group. So this is given by analytic continuation. So take any element from this field. Then H is uniquely expanded as an Puiseux series. Where I is from some possibly negative integer to infinity. Then I don't do it actually, but I think many of you knows that T is nth roots if analytically continuated along X. Well, I erased the most important picture. If we analytically continuate in this way, then this has monodromy given by the roots of unity, nth roots of unity. I think I defined this. This is exponential 2 pi I over n. So this is a complex number. Then there is an argument about, we needed to argue about the convergence, but I neglect and this will be acted in this way. So this is the X as an element of Galois group. Then what I need to compute is this one. So I am trying to compute rho 01 sigma acted on X is by definition, it is sigma inverse X sigma. Now I omit, so this should be written S01 sigma, but just I omit this S01. So what is this? So take same any H again, the same H. Then H is mapped by sigma inverse to sigma inverse AI times T2 I over N is the action which is given by this rationality of the tangential base point 01. So this action. Then analytic continuation by X will give you the following. I am always making mistake. But this is just given here. Then we need to rewind by sigma. And again, the action is on the coefficients. So what we have is this one, AI sigma guzai ni t n2 I. So essentially, the action on X, so this is the action of this guy, is given by just the action on the roots of unity. So now I define the cyclotomic character that is I think for any sigma, zeta n is roots of unity, so it should be something like this. Oh, sorry, sigma. but we know that this is primitive root, so this should be primitive root, so which implies that this A sigma should lie in Z over N, but Z over N cross multiplicative group. And if I write this A sigma N, these elements should be compatible for if we move N. That means A sigma N living inside Z over N cross compatible means that we can take projective limit here. And this is the definition of chi sigma, which is called cyclotomic character, which lives inside this limit, and this limit turns out to be a multiplicative group of the Z hat, profinite completion of Z. Now, I can write this part as zeta n to chi sigma I, because chi sigma is an element here, but taking modulo n, this is just a finite number, and okay. So this implies that the action of rho 0, 1 sigma on x, compare this with the action of x to chi sigma. This is a little bit difficult thing because this is an element inside z hat. So x to some element in z hat is a little bit confusing, but by using topology, we can define this for profinite group, for finite group or profinite group. So you see the action of this guy and this guy on any function h. On any function h is the same, because it is just mapping. It is just mapping this to this. What is this? What is this? If chi sigma is 1, it is x. If chi sigma is 2, it is x to 2. Just doing this thing twice. If this is n, then it is x to n, which implies by density of z in z hat, this is equal, because they act in the same way. Then I will compute a little more difficult thing is f sigma, how f sigma appears. However, now y is I read from right to left for the composition of path P inverse with gamma 1 0 vector. So again, I write the same picture here, but only for y. So here is P. And here is the mirror image of x, which I name gamma 1 0. Okay. Then, rho 0 1 sigma y is sigma inverse P gamma 1 0 P inverse sigma by definition. This is by definition. And I should write this S01 sigma inverse, and this should be S1, S01. But anyway, this is the definition. However, you may put here sigma sigma inverse, and here sigma inverse sigma. And this sigma is not S01, but S10 sigma. S10 sigma, because P I erased, but I think you remember that P is a path from 0, 1 to 1, 0. So this action should be should use this section S1, 0. So this one is again S1, 0. Then I defined F sigma so that this is P times F sigma. And the inverse of this element appears here. So this one is F sigma inverse P. And if you believe the mirror symmetry, then this is nothing but gamma 1, 0 to chi sigma. So this is resulted in F sigma inverse P gamma 1, 0 to chi sigma P here inverse P F sigma. And one can easily prove by continuity again, this is nothing but Y to chi sigma. I think you can believe this. So this proved the theorem which I wrote to here, I erased. So X is mapped to X to cyclotomic character, and Y is mapped to Y to chi sigma, but taking the conjugate by some mysterious element F sigma, which is actually measuring, which comes from the action of the Galois group on this non-trivial path P. Well, so one comment is the Bailey's injectivity theorem, which says that this one actually even for outer automorphism. So this is injected by Bailey, which means that any Galois group can be identified by just looking chi sigma and F sigma. So F sigma has very rich information, and probably it's too rich, so it should be impossible to compute F sigma itself. However, we try to compute F sigma modulo something. So section 3 is GQ acting on F2 hat is very difficult. So we content with some quotient. Or it is not exactly equivalent, but it's similar to consider the image inside F2 hat. And actually, by taking good choice like double commutator and so on, we have very good formula given by Anderson, Ihara, and Coleman independently about this element. But first, because this is student seminar, students workshop, I start with the most easy part. So in the case that n itself, n is the commutator, so that image of F sigma in the Abelianization. F2 Abelianization. I use, because this is very heavy task to write, I use the notation of dash. So one dash is the commutator. And this exercise 1 or example 1, actually this turns out to be trivial. This is what Leila talked, that is F sigma lies in the commutator. How we can do that? We have F2 hat is isomorphic to Galois of M01 over Q bar T. So if we take quotient, this is isomorphic to some smaller field by Galois theory. And actually it is just the fixed field of N. And of course, it's not difficult to compute the fixed part. But if this is enough small, we can find enough functions lying here so that the monodromy action separates all these groups. So then, if this is enough small, then we can explicitly construct this one. So in the case of Abelianization, one can, without difficulty, we can prove that this guy, this field, is given by this, where n runs over all natural numbers. You can prove this by computing the monodromy. So okay, I don't want to use too much time for this. Then what we want is what we want to say is that then, so now n is f2 hat prime. Yeah, the image here.
So n means two different things. Normal subgroup and integer.
Everyone understands things very well, I believe. There are two n's, one n normal subgroup, the other n which is okay, let make n. Okay. Oh, well. Okay, now I believe everyone is content with my notation. Well, what we need to do is that just let an element F sigma, so this F sigma acts on this, but just looking at the action on this smaller field, that is, we let act F sigma on t's nth roots and also 1 minus t's nth roots. But it is easy because of the definition of F sigma is just P inverse, sigma inverse, P sigma inverse, and here should be inverse. So this is the definition of F sigma. However, T nth roots trivially acted by sigma inverse. Then by P, it goes to 1 minus P n. So this is because we choose analytical continuation P. This is real and this should be real. And in embed, we need to compute Galois action. We need to embed this in M10 and in Puis's power series in terms of 1 minus P. But it's easy. This is, I forget the notation, but there is so-called binomial extension, which is 1 minus n over 1 minus, is it true? Yes. Plus something. I am very bad at mathematics, to say the truth. But the point is that these are all binomial coefficients. The point is that it is inside Q. So sigma acts trivially here. So sigma inverse trivially acts. P is just this one. And then sigma again acts, but trivially acts. And then return back by P, which implies that this is mapped to this. And again, mirror symmetry will imply this. Okay, over. What is over? F sigma trivially acts on this field, which implies that the image here should be trivial.
Okay, we can take a break and then you start again.
Hmm?
We can stop and then
Yeah.
next lecture. It's your lecture. Next lecture.
What?
We'll take a break.
Here.
And then it's again your lecture.
Yes. Yeah.
So we can stop 20 minutes?
Yeah, just
You want a couple more minutes?
Okay, so yeah, I may stop here. And but can you give me 10 minutes more in the stop here?